Hey everyone! In this video, we're going to be taking a look at how to combine the chain rule together with some of our other rules for derivatives, such as the product rule and the quotient rule. But before we do that, I want to take a look at how we can sort of simplify the chain rule when we're dealing with functions. And what we're going to develop here is what's called the power rule for functions. So to start off with, we already know the power rule as it relates to just x raised to some power. So if I have an equation like y is equal to x to the n power, if I want to take the derivative of this, I can do that using the power rule. So y prime is going to be equal to, the exponent comes down out front, so we have n times, and then we subtract 1 from our exponent. So now we have x raised to the n minus 1 power. As we move on to the power rule for functions, when we use the chain rule, we can write this in a similar fashion. So let's say we have an equation, y is equal to some function, and we'll call it g of x, and this is raised to some power. Now to find the derivative of this, we know that we have to use the chain rule. The chain rule, we're going to take the derivative of the outside, and we're going to multiply that by the derivative of the inside. So the derivative of the outside, this is just the power rule. So this exponent of n, this comes down out front. So we have n times, and then we're going to subtract 1 away from the exponent. So now my function is raised to the n minus 1 power. And then we need to multiply this by the derivative of the inside. So multiply this by the derivative of g of x. So hopefully you can see the similarities to our normal power rule, but now the power rule for functions, it's the same idea. The exponent comes down in front, we take away 1 from the exponent, but then we also have to multiply it by the derivative of whatever that function is. So keeping that in mind, it's going to make it a lot easier to work with. And now what I'd like to do is take this power rule for functions, and I want to combine this together with some of our other rules. I want to take a look at an example where we combine it together with the product rule, and an example where we combine it together with the quotient rule. Okay, so my first example, I have f of x is equal to e to the x power times x squared plus 1, and that is all raised to the third. So I basically have two different parts here that are being multiplied together, so I'm going to need the product rule. So just as a reminder, the product rule. So if we have a function, capital F of x, and f of x is the product of two other functions, our product rule, we have the first part times the derivative of the second one, plus the derivative of the first one times the second. So we're going to use this to find the derivative. But if I look at my second part here, the x squared plus 1 to the third power, this is a function raised to a power, so I'm going to need to use the rule that we just established before. So let's go through this then. So the derivative, f prime of x. So the first part, we're just going to repeat that, so e to the x. And then we're going to multiply this by the derivative of the second part. So the derivative of x squared plus 1 to the third, let's use the power rule for functions. The 3 comes down out front, and then we're going to subtract 1 away from the exponent. So taking 1 away from the exponent of 3, that becomes 2. And then we have to multiply this by the derivative of the inside. So the derivative of x squared plus 1. The derivative of x squared is 2x, and the derivative of 1 is just 0. So that takes care of our first part, and then we're going to add the derivative of the first piece, so the derivative of e to the x, it just stays the same. And then we'll multiply this by the second piece. And that's it. So we use the product rule in combination with the power rule for our functions, and we're able to find the derivative. The only thing I would like to do to finish this up is just do a little bit of simplifying, make it a little bit easier to work with. So the first thing I see here, I have an e to the x in both terms, And I also have x squared plus 1 squared in both terms. So I'm actually going to factor out both of those things. So we're going to factor out an e to the x, and we're going to factor out an x squared plus 1 squared. Now let's see what that leaves us with. So from the first term, we're left with a 3 and the 2x. And in the second term, we're going to be left with just one of these x squared plus 1s. And then lastly here, just to simplify, in that last set of parentheses, so we have e to the x times x squared plus 1, and this is squared. And then inside this last pair of parentheses, we have x squared plus 6x plus 1. So I think that looks a little bit neater. But here's our derivative. So a combination of the product rule and the power rule for functions, we're able to find the derivative of this. And for my second example, I have g of x is equal to 3x plus 2 over 4x squared minus 5. And this whole thing is raised to the 5th power. So right away, we have a function raised to a power, so we can use our new power rule for functions. But inside our parentheses, we have a fraction. So this is a quotient. So we're going to need to use a combination of the power rule for functions and the quotient rule. So just as a reminder here for the quotient rule, so if we have a function capital F of x, where capital F can be written as a quotient of 2 or more functions, this is going to be equal to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, and this is all over the denominator squared. So we'll do g of x squared. So we're going to need to use this along with the power rule for functions to find the derivative. So that's going to give us g prime of x. Now in this case, we're going to use the power rule for functions first. So this 5 will come down on front, and then we'll rewrite what we have on the inside of the parentheses. And then we're going to subtract 1 away from the exponent. So 5 minus 1, we have an exponent of 4. And now we need to find the derivative of the inside. So the derivative of the inside, we need to use our quotient rule. So f prime of x here, the derivative of the numerator. In this case, the derivative of the numerator is just going to be 3. And then we're going to multiply that by the denominator, 4x squared minus 5. And then we're going to subtract our numerator times the derivative of the denominator. So the derivative of 4x squared, the 2 comes down, so 8 times 2, we get 8x. And the derivative of negative 5 is just 0. And this is all over the denominator squared. So 4x squared minus 5, and this is squared. So again, a combination of the power rule. In this case, we use the power rule first, and then we use the quotient rule to find the derivative of the inside. So here's our derivative. And just like we did in the last one, I want to clean this up a little bit and just rewrite it so it's a little bit more manageable. So we have 5. And then for this first fraction here, I have a fraction raised to the 4th power. I'm actually going to rewrite this as 3x plus 2 to the 4th over 4x squared minus 5th to the 4th. So rewriting it where the numerator is to the 4th power and the denominator is to the 4th power, the reason I wanted to do that is because if I look at my second fraction, I also have 4x squared minus 5s in the denominator on this one. So I know I'm going to be able to combine those together nicely. All right, in my second fraction, let's distribute some parts here. So we'll distribute the 3. That's going to be 12x squared minus 15 for that first one. And then if I distribute the 8x in the second term there, we're going to get minus 24x squared plus 16x. And again, this is all over 4x squared minus 5, and this is squared. So if we keep going, I still have my 5 up front, and then I have 3x plus 2 to the 4th, and the denominator to the 4th power as well. And in this second fraction, we can distribute the negative and we can combine some like terms. So this is going to be a minus 24x squared. So what we're going to end up with is negative 12x squared. And then this is going to be minus 16x and minus 15 all over our denominator of 4x squared minus 5, and that's squared. And then for the last step, instead of writing this as two separate fractions, I'm going to bring these together. Taking a look at the denominators, they're both 4x squared minus 5 raised to some power. So if I multiply these two denominators together, I add the exponents. So what I'm going to end up with for my denominator is 4x squared minus 5 to the 6th power. And for my numerator, I have my 5, and then we have 3x plus 2 to the 4th, and we have our trinomial negative 12x squared minus 16x minus 15. So there we go. I think that looks a little bit nicer, a little bit easier to work with. But here's our derivative. And again, all we're doing here is we're taking our new power rule for functions and we're combining it together with one of the other rules that we have established. In this case, we use the power rule for functions first, and then we were able to use the quotient rule to help us find the derivative of the inside. Whereas the last example, we used the product rule first, and then we were able to use the power rule to help us find the derivative of one of our two pieces.